So this is the review sheets that we use for module 2.3. I'm going to do about half of these problems because there's a lot of problems that we don't need to cover them all. But I'm hoping you guys can use this video to help yourselves do the corrections and then somehow get me the corrections, and then you can submit it or just send me a picture or whatever, and then we can take the retest. So here we go. So the first one is, if you're given a polynomial and then the polynomial's graph, I want you to use some method to find all the factors of this graph. Okay, so the nice thing about this is that when you're doing these problems, you're given some of the factors already. Okay, so right here you can see that we're given the root of -4 and the root of +1. Okay, so now all we gotta do is find the other one based on where it is in the graph, but since we can't see exactly where it is in the graph, we're going to use synthetic division to help us. So if we take our polynomial, we're going to take the root of 1 that we have so far, and we're going to use that as our divisor. And then we're going to take the coefficients of the polynomial. So we have 5, 16, -17, and -4. And we're going to do synthetic division. So if you remember how to do synthetic division, you drop the first number, which gives you 5 here. You're going to multiply the divisor by 5. So 1 times 5 is 5. Then you're going to add. So you're going to get 21. Then 1 times 21 is 21. You're going to add -17 and 21, gives you 4. Multiply 1 times 4 gives you 4. And then add -4 and 4 gives you 0. Okay? Well, this is still way too big, and we could factor this if we wanted to. But since we have another factor, we can just do synthetic division again. Our other factor is -4. And let's back that up. I'm going to put it right here. There we go. All right, so we're going to do synthetic division one more time. Now we're going to use the other factor, or the other root that we have, which is -4. So again, we drop the first number, which is 5. -4 times 5 is going to be 20, -20. 21 plus -20 is +1. And -4 times 1 is -4, which gives us 0 when you combine those numbers. So we went from x to the third at the very beginning. So there's an x to the third. We divided by one of the factors, which gives us x squared. That would have been here. But then we divided by x again, so now we have 5x plus 1. So this 5x plus 1 is one of our factors. But the other two are given to us by the roots. So we have x minus 1, and then we have x plus 4. And those are the roots of, or sorry, those are the factors of our polynomial. Okay. If we look at the next one, okay, it's kind of hard to see on paper, but here on the graph, we can see the blue line crosses the x-axis there at -3. And then here at +2. We don't know the other one because it doesn't pass through a corner of the grid. So again, we're going to do the same kind of idea we just did the last one. We're going to take one of our numbers. We're going to take the 2 factor first, or the 2 root. Okay. Then we're going to take the coefficients of the polynomial. We have 3, 2, -19, and 6. We do synthetic division. So we drop the first number, which gives us 3. We multiply 2 times 3, get 6. Add up 2 and 6, we get 8. Multiply 2 and 8, we get 16. Add -19 plus 16 is going to be -3. And 2 times -3 is -6, which gives us 0. Again, it's too big, so we want to keep going. So we're going to divide again by -3 this time, which is our other root. Again, we do synthetic division. We drop the first number, it gives you 3. -3 times 3 is -9. Add up 8 and -9, you get -1. And -3 times -1 is +3, which gives you 0. So we have our 3 roots. We have the 3x minus 1 that we ended with. And then we have x minus 2 from the root that we have in the graph. And then we have x plus 3. Okay. For those of you who are thinking, like, why is it +3 and not -3? It's because if you have x equals negative 3, when you add 3 to the other side to get x plus 3 equals 0, this is the factor, okay, which is what it comes down to in that problem. Okay, it's the same thing for problem 1. Okay, you take the roots and then you work backwards to make the factor. All right, so those are those two types of problems. The next two examples are just like, it's the same process. Okay, all right, and the next problem, the next set of 4, I'm actually going to do the last two problems. I'm going to do 6 and 7, or sorry, 6 and 8. Okay, so the first thing we have to do is we have to factor our quadratics here. So let's do this one first. So two numbers that multiply to give you 18 and add up to give you 9. So that would be x and x. Then we're going to do positive 6 and positive 3. So 6 times 3 is 18, and 6 plus 3 is 9. We have to factor the other side as well. Two numbers that multiply to give you negative 12 and add up to give you positive 4 are going to be positive 6 and negative 2. So what we're looking to do is figure out what is common and then what's missing. Okay, so if we look at the denominators of both sides of our equal sign, they both have plus 6, which is great. We don't need to put that on the other side, but the left side has x plus 3, but the right side doesn't, so this needs an x plus 3. Whereas the right side has x minus 2, but the left side does not, so this needs to be x minus 2 over here. Okay, now that our denominators are the same, we can get rid of them, and we're going to multiply, we're going to multiply the 2 times x minus 2 gives us 2x minus 4 equals, then we do the same thing on the other side. 4 times x plus 3 is 4x plus 12. Okay, and then we're just going to solve that. All right, so I'm going to subtract 4x from both sides, which gives you negative 2x. And I'm going to add 4 to the other side. So that goes away, and that equals 16. I divide both sides by negative 2, and then x will equal negative 8. Okay, so that's part of the answer. All right, if you remember, if you read the directions, it says find the domain restrictions and solve. Okay, for the domain restrictions, we're going to take our factors of our denominator, which are x plus 6, and set them all equal to 0. X plus 3, and x minus 2. You don't need to do the x plus 6 twice because it's already done once, and that's all it needs to be. All right, we need to find out what x cannot be, because if x is 0 in the denominator, or sorry, if you have a 0 in a denominator, you have an undefined fraction, and that's no good. So we got to make sure that we can't have any x or zeros in the denominators by taking the factors and solving them for x if you set the factors equal to 0. So x cannot equal negative 6, negative 3, and positive 2. Okay, if x equaled any of those three numbers, you'd have 0 in one of the denominators and you'd be undefined, so that'd be bad. Okay. Next, number 8. Okay, this time we have 3 fractions. Okay, so it might help to just look at the factor, or the fact that 2 of our fractions have a denominator of 1. Okay, so if we look at our 3 denominators, we have 1, we have x, we have 1. Okay, I like to make this little chart. Some students really like it, some students don't need it, whichever one works for you. So these are our 3 denominators. So what is the first one missing that the other 2 have? Well, it's got a 1. The last denominator has a 1, but it's missing an x. Okay, the middle one has an x. It's missing 1, but you don't really need to put a 1 there. It could be 1 times x, which is still just x. So it's not really missing anything. But I'll put a 1 there just to hold its place. And the last one is missing an x as well. So what we're going to do is we're going to have x here. We're going to multiply this 15 by 1, and then the negative 2 is by x. So if we multiply all our numerators together with the things that we're missing, we're going to get x squared minus 15 equals negative 2x. Okay, now what we're going to do is set this equal to 0 by adding 2x back to the left side. So we have x squared minus 2x minus 15 equals 0. Okay, so what we're going to do now is factor this. So what 2 numbers multiply to give you negative 15 and add up to give you negative 2? That would be negative 5 and positive 3. I made a mistake. That should be a plus. Hold on. Okay. So it should have been a plus 2. My apologies. So now what two numbers multiply to be negative 15 and add up to be positive 2? That'd be plus 5 and negative 3. So that's what it should be. Okay, now we're going to solve both of these for x. So x will equal negative 5 and positive 3. All right, again, we do have to find the domain restriction, so whatever x cannot equal, we only have one domain with an x in it, so we're going to have x cannot equal 0, and that is it. Okay, so those are the two different parts of the answers for number 6 and 8. Okay. All right, again, as a quick reminder, I know I didn't say this in the video here, but once you get the denominators to be common, you can cross the denominators out, and then you can just multiply what was missing to the numerators, and that becomes your equation. Okay. All right, moving on. We've got some systems of equations. Let's do the top two. Okay. So it says find the point of intersection. All that's saying is find the. That's just basically the same thing as saying solve the system of equations. So what we're going to do is I'm going to move the one on the left. I'm sorry, on the right-hand side underneath the one on the left. So I'm going to put negative 9x minus 4y equals negative 11. Okay, now what I want to do elimination is get one of the variables to cancel itself out. I'm going to do this by multiplying the top equation by 2. That will allow me to have positive 4y and negative 4y, and when I add those together, they will cancel themselves out. So I get 2x plus 4y equals 18. Okay, now what I can do is cancel these two things out, so I get negative 7x equals positive 7. I divide both sides by negative 7, and I have x equals negative 1. Okay, I do have to put this answer back into one of the equations. I'm going to put it in the top one. So I have negative 1. I'm going to put it over here. Negative 1 plus 2y equals 9. Okay, so now what we're going to do is solve for y. I'm going to add 1 to the other side. So we get 2y equals 10. Divide both sides by 2, and y will equal 5. Now I should put my answer as a form of a point because this is our point of intersection. So it would be negative 1 comma 5. X comma y. All right, now I'm going to do number 11. This one's set up doing substitution. Okay, so I already have something solved for y. I can just put this 7x plus 11 in for this y right here. So I can replace that y with 7x plus 11. How it looks is at negative 8x minus 5 times 7x plus 11 equals negative 12. Okay, so all I did is replace the y value with what y is equal to on the top. So we're going to get negative 8x minus 35x minus 55 equals negative 12. I combine the x's together, I get negative 43x. And I'm going to add 55 to this side, and it'll equal 43. I divide both sides by negative 43, and I have x equals negative 1. Again, I have to put that answer back into one of the equations. I'm going to put it in the top one. Y is equal to 7 times negative 1 plus 11. And y will equal positive 4. Again, because it is a point of intersection, I'm going to write it as a point. Negative 1 comma 4. There you go. All right, next two to do. We're going to solve these two equations. Okay, we're going to do the top two. We're going to do 13 and 15. Okay, so if you look at 13, you'll see we have 3x cubed minus 24x squared minus 27x. They all share in common a 3. They all have a 3 in them, and they all have an x in them. So we're going to take a 3x out. What's left over when we divide each one of these terms by 3x is x squared minus 8x minus 9. That's equal to 0. So now we've made our a quadratic inside our parentheses, we're going to factor that quadratic. So what two numbers multiply to give you negative 9 and add up to give you negative 8? That's going to be negative 9 and positive 1. We still have the 3x on the outside, because what we have now is 3 different factors, because there's 3 different x's. Okay, so we set each one of the factors equal to 0. So 3x equals 0, x minus 9 equals 0, and x plus 1 equals 0. We solve all of these for x. So x is going to equal 0, 9, and negative 1. For 15, same kind of idea, except we don't have a number that goes into all three, but they all have x that you can take out. If you take out an x, you're going to be left with x squared minus 6x minus 27 equals 0. Now with the quadratic inside the parentheses, two numbers that multiply to give you negative 27 and add to give you negative 6 is negative 9 and positive 3. And the x is still out in front. So now we take all three of our factors, x equals 0, x minus 9 equals 0, and x plus 3 equals 0, and solve them all for x. So x will equal 0, 9, and negative 3. Okay. All right, moving right along, we have some graphs. Okay, so we want to know, how did the transformations affect our graph? Okay, so let's do the graph first, and then we'll get into the descriptions on the right-hand side of the box. So you're given the graph of y 1 over x. Okay, the blue lines are 1 over x, and we want to change the graph based on our transformations. I'm going to change color so it's obvious which one is which. All right, so we have two changes. The plus 1 on the bottom, that's inside the function, so this is going to make the graph go to the left by 2. And the plus 1 on the outside, which is to make the graph go up by 1. Okay, so if you think about our asymptotes are on the axes, the x and the y-axis. So what's going to happen is your vertical asymptote on the y-axis is going to go to the left by 2. Okay, and then the horizontal asymptote, which is on the x-axis, is going to go up by 1. All right, we're just going to redraw the graphs based on where the asymptotes are. It's just a sketch, so it doesn't have to be too accurate. So there's our graphs. So that's what the graph should look like for these functions. Okay, so now we want to figure out where our values are. Okay, for the y-intercept, we're going to put 0 in for, here we go, let's go back and erase this part so we have some more room. For our y-intercept, we're going to put 0 in for x, so we have 1 over 0 plus 2 plus 1. Okay, so we're just going to solve that. So you have 1 over 2, because 2 plus 0 is 2, plus 1. So what's 1 plus 1/2? That's 3 over 2 as a fraction. Okay, so our y-intercept is 0, 3 over 2. For your vertical asymptote, well, we have here, our vertical asymptote is the one that goes up and down, and that is now at x equals negative 2. Our horizontal asymptote goes, whoops. Okay. Horizontally, it went up by 1, so now it's going to be y equals 1. Our domain. So what exists? What x values exist in our graph? Well, if we go from left to right, we have to skip over the vertical asymptote. So we go from negative infinity to the vertical asymptote, which is at negative 2. And we start up again at negative 2 and go towards positive infinity. So the only thing it can't be is negative 2. For the range from the bottom to the top, it's the same kind of idea. Starting at the bottom, we go from negative infinity, and then we go up till we hit to the horizontal asymptote at 1. And then we start up again at 1 and go to positive infinity. And that is your range. All right, let's look at the next one. So we have our graph, and we want to look at our transformation. So -3 is our horizontal shift going to the right by 3, and our +2 is going up by 2. So our asymptotes, we go to the right by 3 and put in our asymptote. And the horizontal asymptote goes up by 2. Okay, so our y-intercept, what do? I'm going to erase our little markings here. We're going to put 0 in for the x term. Oops, -3 plus 2. So we have -1/3 plus 2. Okay, if you put that in your calculator, you're going to get 5/3. So you're going to get 0, 5/3. To find the vertical asymptote, the one that goes up and down, since we moved it 3 to the right, it is now x equals 3. For the horizontal asymptote, since we moved it up by 2, it is now y equals 2. The domain is the x values that exist in the graph. Oh, sorry, you know what? I forgot about the graph. There, we'll just draw the graph in real quick. All right, so for the domain, what x values exist in the graph? From left to right, we start at -infinity. We go in the graph till we hit the vertical asymptote at 3. And we start up again at 3 and go to +infinity. For the range from the bottom to the top, again, we start at -infinity. We go to hit the horizontal asymptote at +2. Start up at +2 again, go to +infinity. Okay? The same kind of thing exists for all these different graphs. It's the same process, same patterns. Okay? So we're going to move on to some of these problems. All right? So let's see which ones we want to do. Let's do the first 2 again. Okay? So we want to figure out what all this stuff is. So Martin's Catering will cater a banquet for $14 per person with an $80 fixed setup charge. So what went on to the total cost of the banquet of 150 people attend? Okay, so it's $14 per person. Let's go back to blue. There we go. So it's $14 per person. There's 150 people. And there's an $80 setup charge. Okay, which gives us $2,180. If we want to know the average cost per person, we take this value and then we divide it by how many people are there. So there's 150 people divided by 150, and that equals $14.53. So these are your 2 answers for the 2 separate questions. So for part B, we want to write an equation for the cost. So the cost is C is equal to the amount of money it costs per person, which we don't know. That's going to be X. All right, plus the fixed cost, which is $80. All right, if we want to find the average, we do what we just did up top. We take the total cost divided by the number of people. So if the total cost is 14x plus 80, we divide that by how many people are coming, which is the x value. So that's the average cost. Okay, so A for average. All right, now if we want to do part D, we are given the average cost, and we want to find out how many people came. So we're going to put in 1450 for A. We're going to set it equal to 14x plus 80 over x. Now what we have is we have a rational equation like we've done up previously. What are we missing in our denominators? This left side, the 14.5, is missing an x. So we're going to multiply this side by x, which means our denominators can go away. So we have 14.5x equals 14x plus 80. We're going to subtract 14 from both sides. We're going to have 0.5x equals 80. And once we divide both sides by 0.5, X will equal 160 people. Okay, let's go to the next one up top here. Head & Facets Jewelry offers custom jewelry options for customers. There's a $25 consultation fee and a $10 per hour fee to make the jewelry. Okay, so what's the total cost and what's the average cost if it takes 3 hours to make? So it costs $10 per hour. We're working for 3 hours, and it's $25 just to see and talk to them. Okay, so that gives us $55. So we're going to find the average of what it cost. You're going to take your 55 and divide it by the hours you worked, which is 3, and that gives you $18.33. So these are your two answers. So we're going to write an equation to represent the cost. The cost is the $10 fee per hour times X plus the $25 consultation fee. For part C, find the average. So the average is going to equal the total cost divided by how many hours you worked. Okay, and X is representing the number of hours. Again, here we go for the average prices. If the average price is $15, how much did it cost to, how many hours did it take? You have 10 times X plus 25 over X. Again, the left side is missing the X because it's a rational equation. So we multiply X to the other side. We don't need that anymore. So we have 15X equals 10X plus 25. Subtract by 10 from both sides. You get 5X equals 25, and X will equal 5. So it's 5 hours. Okay, so the other two, again, the next two questions do the same kind of idea. It's just more questions to do. All right, I think this is the last page. So we have some work questions. So we'll do, which ones should we do? We'll just do the top two again. All right, so we set this up. Liz can paint a room in 10 hours. So we have Liz, and we have Jack. Jack can paint the same room in 8 hours. So we have rooms that they're painting, and the hours it takes. Actually, you know what? Let's go back. We're not going to do hours, we're just going to do time it takes. Okay, so Liz can do one room. It takes her 10 hours. Jack can paint the same room, so one room, in 8 hours. We want to know how long will it take them to paint the room together. So one room, and we're not sure how long it's going to take. Okay, so we set up our little chart that we showed you a little bit earlier. So we have 10, 8, and X as our denominators. There's a couple ways you can do this. There's like a simple way that is a little bit bigger numbers a lot of times, or an easier way it's a little bit harder way, but it's smaller numbers. Okay, I'm just going to do the quick and dirty method. All right, so 10, 8, and X are our denominators. What is 10 missing? It's missing 8 and X. 8 is missing 10 and X. And X is missing 10 times 8, which is 80. Okay, so we're just multiplying the denominators that are missing to those numbers. So when we have this, now we're going to multiply the Liz by 8X, the Jack by 10X, and the together by 80. When we do that, we get an equation. 8x times 1 is just 8x, plus 10x times 1 is 10x, and 80 times 1 is 80. All right, that becomes our equation we have to solve now. So we combine the like terms. We have 18x equals 80. Divide both sides by 18, and x will equal about 4.4. Okay. Do the 20s, or sorry, we can do 27 the same way with Kayla. So we have Kayla, and we have Wilbur. She's digging a hole, so this is holes. This is time. Kayla can dig one hole in 7 hours. Wilbur can dig the same hole in 10 hours. How long would it take them to work together to dig one hole? Okay. So again, we make our little chart. We have 7, we have 10, we have x. So 7 is missing 10 and x. 10 is missing 7 and x is missing 7 times 10, which is 70. So we multiply those by our numerators. We have 10x, 7x, and 70. We don't need the denominators anymore, so we get 10x plus 7x equals 70. Add the two like terms on the left, you get 17x equals 70. Divide both sides by 17, and you get x is equal to 4.1. Okay, and that is it. Okay, so the rest you can, if you'd like to try those on your own to get an idea of how to do them, but that was how to do the problems you need to do to get ready for the retest. So again, if you're doing if you're watching this video, please do some of the corrections or do corrections on specific standards you need to fix for the first test that we took. And this is unit 2 or module 2.3. When you've done the corrections, just let me know. I can look them over, and then we can set up a time and a way for you to take the retest.